So we know that if two triangles are congruent, that means all pairs of sides are congruent, all three pairs, and all three pairs of angles are congruent. So that's six pairs of things to show that are equal in order for the triangles to be equal. Well, it turns out we've got some shortcuts. We've got several, actually. We're going to learn two today. The first shortcut to showing that triangles are congruent is called SSS. And SSS stands for side, side, side. So you can look here at this picture and see here is a pair of sides, right? That is representing that AB is congruent to RS. Here, this is representing that BC is congruent to ST. And this triple mark is representing AC is congruent to RT. So we have three pairs of sides. This is SSS. And this is telling us that if the three pairs of sides are congruent, then the triangles are congruent, then everything else about the triangles is congruent, including all three angles. So SSS, three equal sides, means exact same triangle. SAS stands for side, angle, side. Now we don't have letters here, so I'm just going to mark. Here's two pairs of sides and what we call an included angle. Included angles are in between, or we use the word sandwiched between the two sides. So if you have two pairs of sides and an angle in between that are equal, then the triangles are congruent, then everything else about those triangles are equal. Now we're going to introduce an concept called free sides and free angles. Free sides happens when triangles share a side. So those two triangles here share this side and it's equal to both triangles. So anytime you have this like overlap, you have to mark it. Sometimes it's easier to tell than others, like this triangle is going to be congruent to this triangle. Those are overlapping triangles and they share that side. That's the toughest one to see. The other ones you can kind of see right away, the side they share. That's going to be considered a free side. A free angle is going to happen with vertical angles. You remember that when lines cross, you get two angles across from each other that are always equal, that are called vertical angles. We're going to know those angles are equal kind of for free, the vertical angle theorem. So what we're going to do is look at our picture, look closely at how the picture is marked, decide if it's a side-side-side picture, a side-angle side picture, or neither. If it's congruent, we're going to complete the congruent statement, and the order of the letters is going to matter. So here, if I look at how the picture is marked, I see a side, I see another side, and I notice an included angle. That's a representation of side, angle, side. How would the letters go? L, K, J. L matches with F, K matches with D, J matches with E. It has to go in that order. Next one, what's represented is a pair of sides, a pair of sides, a pair of sides. That's the side, side, side postulate. M goes with P, O goes with Q, N goes with R. Has to be in that order. And onwards we go. So each time you're studying the picture, you don't have to always remark it, but it's kind of helpful because sometimes I might say, oh, that's side, angle, side. Is it? It has two sides, it has an angle, a pair of angles, but that angle's kind of in the wrong spot right here. It was supposed to be right there. So, and since it's not, this is a none, and since it's a none, we don't write the congruent statement because they're not congruent. Now we'll circle back to free side and free angle. So here I see a pair of sides, another pair of sides, and nothing else is marked. So that alone isn't enough to say side, 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 but when I notice this free side, right, so I've got a free side, now I have enough to say side, side, side. And you have to mark it, and you have to do the order of the letters CDA, CBA. If there's not a free side, like I'm looking at number 5, I see 2 pairs of sides. There's no third side. There's no free side. This is a none, and there's no congruent statement. The next one, pair of sides, pair of sides. I don't see a pair of free sides, but what do I notice? You're right, pair of free angles, side angle, side. Pair of free angles. And I have to be real careful with these letters. IGH is going to go with FGE. This is what I'm going to call a bow tie picture, because it looks like a bow tie. And we'll have a couple kinds of bow ties. This is what I call a folding or a flipping bow tie, because it just corresponds right across from each other. These two correspond. If I look at the next one, I see a pair of sides, and a pair of angles. But is it side angle side? Is the angle included between the sides? No, it's not. None and none again. The very last one is side angle side, because now I see 2 sides and that angle's right in between, so that's side angle side. And if I say XZY, that's going to go with XVW. All right, last thing. So the last thing is extra. Extra stuff. Extra stuff. So they're going to give you a pair of sides, for example, that you mark on the picture. Another pair of sides that you mark on the picture. No one wants to mark it on the picture. You have to mark it on the picture. Then look at the postulate they want you to create, side, side, side. So I have 2 pairs of sides. I need what? You're right, a third pair of sides. Now I state those pair of sides. CA is congruent to DO. I could have said AC congruent to OD, but I have to keep it in corresponding order. So the question was asking, what extra thing did I need to make side, side, side? I needed that extra pair of sides. Now that one was a little easier. Let's do a little tougher one. They're only giving me CT and DG. And they're telling me there's 2 solutions. So 2 ways I could do side angle side. So in these problems, I want you to think of clockwise and counterclockwise, or going towards the right and then going towards the left. If I go this way to do side angle side, I can get it, right? I could take angle C congruent to angle D, and then similarly CA congruent to DO. That gives me side angle side. But I could also go the other way, this way, towards the right, and take angle T congruent to angle G, and then TA congruent to GO. Oops. Congruent to GO. It's hard to write on the bottom of the page. GO. Here, I'll write it up here. TA congruent to GO. And that would be the last thing I need. You might not have this page in your packet, but I'm just going to show you really quick. This is that idea of included. So we use that word a lot, included, like an included angle. So this angle here is included between the 2 blue sides. That's what this is saying. Angle Y is included between those 2 sides. So it's just like something to look at. And then the idea of included side, this is saying that side XZ is included between these 2 angles. So sides are included between angles. Angles are included between sides. So there we go. Side, 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 side angle, side.